There we go. And I'm ready to perch. All right, I'm actually gonna start on the right side and then we'll do the left-hand one last because the right-hand side goes back through our BPA log BAP stuff where we take our exponential that is a base, and we'll even do it in the colors, our base with our power that equals some argument, and we convert that with log base B of A equals P, equals that power, BPA log BAP. So for this first one, we're trying to switch it to exponential form. Our first step should be to find our base. What's our base? 3. Turn our audio down. It is in this corner. I can hear it up here. 3. What is our power? 5. Oh. Right at my door. And what's my argument? 243. Thank you, sir. Got to knock louder than that. None of us are there. All right, we got our 243. That's how we convert it around. We didn't have to do any calculations. It's just moving the stuff. Down below, it's very similar. Let me get the highlight on here. We're just going the other direction. So down here, we're going to take our log. I'm still hearing the audio from this side of the room. What's our base on the bottom one down here? 2. So we're going to have log base 2 of, what goes next? The 512. And it's going to equal 9. So we're just switching them back and forth. We get used to switching them back and forth so that when we look over here at our evaluating stuff, we can say, well, the piece I'm missing is that power. And we can take this missing power and switch it around into exponential form so that we have our base of 4 to some mystery power that we know is going to equal 16. So what does that power have to be? 2. 4 squared gives 16. So log base 4 of 16 equals 2. That's what we mean when we evaluate. Ooh, love it. Log base 4 of 8? Is that what it says? Ooh, that's super grosser. Switch it to 16. Because 8 would be a fraction. I want to say it would be 3 halves. Yeah, it would be 3 halves. Super gross. Switch it to 16. I will make a note of that. Sorry, that's what happens when your first period. You're kind of the guinea pigs. That means it didn't update when I printed it, because I probably fixed that before. Okay. So we're not going to be doing too much with our BPA log BAP today. What we're actually going to do, and it feels really strange because we never start this way, is we're actually going to start with graphing. Because, remember, we talked about logarithms yesterday when we introduced it as the inverse operation of raising to the exponential. And we talked about finding inverses when we take our x, we take our y, and we make them change places. So we're going to do exactly that to make some graphs. So, there we go. So I'm going to pass out some graphs. We are going to do 3 graphs today. And they're slightly bigger graphs this time. I made them kind of that. So this left-hand one, you guys can get started on. We can do this, 2 to the x. That was last chapter. Purple and yellow.
Okay, it doesn't matter.
Okay. I can't find any black ones.
No.
All right. So we are going to graph both of these onto the same graph. So these two things are going to go on the one graph so that we can see what's happening here. So 2 to the x, this is exactly what we did in the last chapter, where we start with our parent table. We pick our x's to find our y's, and we want that good view of the middle. So we use -2, -1, 0, 1, and 2. And we wind up with an asymptote right at y equals 0. Those pieces are always the same for our exponential parent functions. Like we worked with those a bunch of Crenshaw. When we would evaluate these, 2 to the x, 2 to the power of -2, that's 1/4. Again, you can put it in the calculator. Or you can remember that a negative exponent makes it flip upside down. So it becomes 1/2 squared gives us 4. So our second one is 1/2 to the first, which is 2. Anything raised to a 0 exponent is 1. 2 to the first is 2. And 2 squared is 4. So when we graph up this parent function, it looks like -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, something like this. And we have that asymptote right at y equals 0. So it's never crossing my x-axis. We wound up with a domain of all real numbers, or from -infinity to +infinity. And we have a range from 0 to infinity. Again, this is last chapter stuff, so it should be hopefully at least vaguely familiar. Because we use exponentials in the creation of the log. Because these two pieces, let's see if you make a point to everything. These are inverse operations. That was the definition we used when we wrote what a logarithm was. It is an inverse operation. When we do inverses, we take our x's, we take our y's, we make them change places. So when we look at this table over here, I'm going to take my x's and my y's and make them change places. So when we go over to make the table for g of x, my stylus. What we're going to do is we're going to take, there we go, the table from 2 to the x, and if it used to be in the x's, Now it's going to be in the y column. And if it was in the y column, now it's going to be in the x column. So we're going to go down my y's with my -2, -1, 0, 1, and 2. And my x's for my logarithmic function are going to be the y column for my exponential. My 1/4, 1/2, 1, 2, and 4. Remember, we're taking all of our x's and all of our y's and making them change places. So my asymptote is no longer a y equals, it's going to be x equals 0. Domain has everything to do with our x values. Range has everything to do with our y values. So those are going to change places too. What was the domain becomes the range. Our range is going to go from -infinity to +infinity. Our domain is going to go from 0 to infinity because it changes the places. This went up here. This went down here. All of these values went over here. And all of these values went over here. So everything that was an x became a y. Everything that was a y became an x. Now what we're going to do is we're going to graph this function. So when we plot our points, we'll have an x of 1/4 and a y of -2, which is a point way down here. We have an x of 1/2 and a y of -1, which is right about there. X is 1, y is 0. X is 2, y is 1. And x is 4, y is 2. And remember, we have that asymptote, which I'm going to just draw in here just for this one, where x equals 0. So the asymptote on our logarithm is now a vertical line. So when we connect it up, it's just not going to cross my y-axis. So we are going to build logarithms in terms of exponentials. And the piece that's really important to notice that I didn't point out before is that the base of the exponential we used is the same as the base of the logarithm. So we used 2 to the x to build log base 2. Whatever our parent function is going to be, it's going to be that base. And I know these are weird. We're going to do 2 more of these. We're only going to do parent tables today. We'll do transformations tomorrow. Yes, dear. Yeah, let me let you pass. All right, let's look at the next one. So here we have 4 to the x and log base 4. So we use 4 to the x to make log base 4. I'm not going to graph the 4 to the x this time so that we don't wind up with a super complicated paper. But I still need to make the table for 4 to the x. We still need to make this piece because we use that to make our table for log base 4. So when we look at 4 to the x, that's when we use the x's that we pick to find our y values. And we use those x values from -2, -1, 0, 1, and 2. And it's going to have an asymptote where y equals 0 for this parent function. That part is always the same for the exponentials, every single time. For our y values, we're going to evaluate 4 to the x at each of these x's. So 4 to the power of -2, well, the minus makes it 1 over. The 2 is 4 squared. 4 squared is 16. 4 to the -1, that's 1 over 4 to the first, or 1 over 4. 4 to the 0, anything raised to the 0 power is 1. 4 to the first is just 4, bless you. And 4 squared is 16. For all of our exponential functions, we had a domain from -infinity to +infinity. And all of the parent functions had a range from 0 to infinity. We can fill all that in without having to graph anything. And we're going to fill in a similar amount of stuff for our logarithm, because we know that 4 to the x is the inverse of log base 4. These are inverse functions. That was the definition of a logarithm. What was an x becomes a y, what was a y becomes an x. So when we're looking to build our table over here, we're going to take that exponential, and if it was an x, it becomes a y, and if it was an y, it becomes an x. So I tend to fill in the same order that I filled in on the exponential. So I'm going to do my y's first on the log. -2, -1, 0, 1, and 2. And then we take those same y values and they become our x values. So our 1 over 16. 1 over 4. 1, 4, and 16. And then instead of our asymptote being at y equals 0, it's going to happen at x equals 0. And we can also figure out our domain and range of this parent function here, because we know, since these are inverse operations, that was the range becomes our domain. So our domain is going to go from 0 to infinity. And we know what used to be the range, or what used to be the domain becomes the range. So our range is going to be from -infinity to +infinity. So we can find a whole lot of stuff about these logarithmic graphs before we even get to the graphing part. I am not going to graph the 4 to the x on this one. I'm just going to graph my logarithm, which means the first thing I'm going to do is I'm going to put my asymptote up here, that x equals 0. That is a vertical line right here that we cannot cross. Asymptote still means we can't cross it. It's a wall. It's just a vertical wall instead of a horizontal wall. Then we're going to plot up all of our points. X is 1/16, y is -2. So it's going to be really, really close to that wall, but not crossing it. X is 1/4, y is -1. Again, really, really close to that wall, but not crossing it. You good? Okay, just checking. X is 1, y is 0. X is 4, y is 1. And 16, 2 is way off the graph over there. So we're going to connect these pieces up and not cross the asymptote. You can get real, real close to it, but it does not cross. Let me write your best. Okay, so one more like this. But this time I'm not telling you what the parent function is. We have to figure it out. We're just asked to graph log base 3 of x. So when we're looking for our exponential parent function, which one's it going to be? 3 to the x. So we base everything off 3 to the x. And if you want to build the parent table for 3 to the x itself entirely, you absolutely can. We are going to wind up doing transformations on logs as well. So if you want to be writing 3 tables, that's totally fine. Your other option is to come over here to your log 1 and just build it right over here. We just build it backwards. I'm going to keep going the way we had been doing because it's a surefire way to have it. So on our exponentials, we just take our x's, our -2, -1, 0, 1, and 2. That parent function had y equals 0. Which means I can just come over here. I know already that these are going to be the y's in my logarithm. My -2, -1, 0, 1, and 2. And I know my parent function for my logarithm is going to happen where x equals 0, because what was a y becomes an x. So these pieces are always going to be the same for our logarithmic parent functions. Our y values we do exactly the same way, or the y values for our parent are exactly the same way. 3 to the power of -2, that's 1 over 3 squared, or 1 over 9. 3 to the -1, it's 1 over 3 to the first, or 1 over 3. Anything raised to a 0 power is 1. 3 to the first is 3, and 3 squared is 9. Those are our x values. Again, with logarithms, as we get more and more practice with them, if you just fill in this table, that's fine. This table is just a tool for you to use. I'm never going to ask you to graph an exponential and the parent function for the logarithm and a transformation for a logarithm. It's just too many things. So for the most part, we're just going to focus on the logarithmic graph and its transformations. So the exponential is just a tool for you to use. We still wind up with these same values: 1/9, 1/3, 1, 3, and 9. We also know that the domain for our logarithms, it was the range for our exponentials. That's our 0 to infinity. And our range for our logarithm was the domain of the exponentials, which was all real numbers, or from negative infinity to positive infinity. So we're going to plot this up. I'm going to put my asymptote up here, my x equals 0. This is the wall it can't cross. I'm using yellow on this one. There's our wall, our asymptote. And we're going to plot our points. When x is 1/9, y is -2. So it's really close to our asymptote, way down here. When x is 1/3, y is -1. Again, pretty close to my asymptote right there. X is 1, y is 0. X is 3, y is 1. And x is 9, y is 2. So our graph is going to look like this. Questions on our parent function, because this makes a parent function for a logarithm. You want to know what we're going to do with it tomorrow? Oh, snap. Okay, so I'm actually going to put up the first slide of tomorrow because there's a lot of words to write and I want us to have plenty of time. So if you write it down today, it saves us time tomorrow. Because we're going to do transformations using logarithms. This is our transformation form. We're going to work with this tomorrow. Like, this is legitimately the first slide I'm going to put up tomorrow. All this is doing is talking about transformations. This is kind of the most important piece here. Okay? So I want to make sure you guys have time to work on stuff, ask questions and things like that. The graphs on the back of homework 1, you can do the parent functions on now. So take some time and go do the parent functions. The transformations we'll talk through tomorrow. But that's what those are. So you're going to have 2 parent functions for those 2 graphs on the back. So you can get your parent table and your parent function off of this, and then tomorrow we can do the transformation functions. Okay, so I will leave this up just so that you guys have plenty of time to write it down, get anything you need off of it. I know this page had a lot of things on it. And we'll talk through the rest of it tomorrow because we have 10 minutes right now to the end, and I want to give you guys some time to work on stuff and ask questions and things. I do have a lot of people that are still missing that skills check that was on Canvas. It was an e-learning assignment. So I redid my missing assessments board yesterday because honestly, I was running out of spaces because I was writing. I got a lot of people with missing assessment. They had skills check that was an online assignment, went in as a quiz. So a lot of us had zeros in for a quiz because we didn't do the online skills check. It should still be open. It's up on Canvas. It does have a time limit on it, so I don't know that I'd start it right now because there's only 10 minutes, but soon, do it soon, okay? It automatically grades, so it'll get the score in really fast after you take it, but there's a lot of us that have that sitting as a 0 right now, okay? There's more people that haven't taken it than have, okay? Because I wrote out like 80 names, most of them were for that little skills check. Yes, dear.